Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. We're given an augmented matrix in echelon triangular form with parameters A, B, C, D. Your job is to pick values so the system has no solution, and other values so it has infinitely many solutions, and then decide which parameters don't change solvability at all. This matrix is already upper triangular, so we can read it as three equations. Notice how the last equation only involves x3. That's usually where solvability breaks or stays safe. The only way to lose solvability in echelon form is to end up with a contradiction like 0 equals 5. So we'll hunt for when our bottom row can turn into that kind of impossible statement. This last row is the only place the pivot can disappear, because the first two pivots, the 1 and the 4, are already fixed and non-zero. When D is non-zero, the last equation always determines x3. No contradiction is possible here, no matter what C is. Once x3 is fixed, the second equation fixes x2, and the first fixes x1. So we get a unique solution whenever D is not 0. If the pivot disappears, D equals 0, the last equation stops talking about variables and becomes a pure consistency check. Is 0 equals C, true or false? So everything now depends on whether C is 0 or not. To force a contradiction, we want the last row to become 0, 0, 0 or C, with C not 0. That is exactly D equals 0 and C not 0.
Here is a concrete pick. Set D equals 0 and C equals 1.
Then the last equation reads 0 equals 1, and the whole system is impossible, no matter what A and B are. To get infinitely many solutions, we want the pivot to disappear, but without contradiction. That means D equals 0, and also C equals 0. Turning the last equation into 0 equals 0. With no restriction on x3, we can choose any value for x3, then solve uniquely for x2, then x1. A free variable means infinitely many solutions. So a simple example is D equals 0 and C equals 0. Again, A and B can be anything. The first two rows already have guaranteed pivots, so changing their right-hand sides can't create a contradiction by itself. Parameters A and B only change the target values and equations that remain solvable once pivots exist. They don't decide existence versus contradiction here. But C and D control the bottom row, where the pivot can vanish and where contradictions can appear. So they directly control solvability. The entire story is in the last row. Either it gives a pivot, unique solution, or it becomes a consistency check that can either contradict, no solution, or vanish, infinitely many solutions. Since the first two pivots are guaranteed, A and B never decide solvability, only the specific values of the solutions. Watch the next video to learn more. Next, we'll visualize how pivots and free variables connect to geometry in R3, and you'll be able to spot no solution versus infinite solutions at a glance.